We're here with William Randall from STARC and Robert Booth with us here at Oncore. And we're really excited to start giving these monthly talks on a specific ICRA related topic. We've heard over and over again from clients that kind of continuing education and these specified talks on ICRA topics are not very accessible. So that is the point of these. We're really excited to offer them to you. We're going to have this kind of separated into 3 sections. Bob is going to give a quick talk, about 20 minutes, on the different barrier types, how they fall into the ICRA matrix, and some of the standards, including NFPA 241. We're going to talk to William Randall from STARC and talk about how they develop their ICRA compliant products and why, and some of the troubles that we've seen in the field and that they've seen in the field. And then we're going to do kind of like an open Q&A for anyone. Most people here have taken our in-person class or online class. So if you have any questions about the class or something that you've seen on your site, we'll have that time then. So I'm going to hand it over to Bob to kick it off.
Oh, good. Thanks, Olivia. Yeah, so we started developing these free 1-hour introductory class topics that we want to talk about every month, just to kind of keep the conversation going from dovetailing off the classes that we give. And one of the things that I talk about in detail during that session in the ICRA class is the barrier protection. So we thought it would be great to start off with barrier protection, since it is one of the most hardest things to do, other than negative air and delivery of negative pressurization, which we'll talk in later sessions. But why the barrier protection is important is really for a number of reasons. One, we want to isolate the construction from the occupied space, and we'll talk about what that means. We want to keep the facility open, so we can't just shut down the facility because we're doing construction. And we also want to, keep the project compliant with the life safety code and some infection control rules. When I was a young infection control practitioner back in the 1990s, my first year, I had to investigate a bunch of aspergillus infections that were occurring in surgery. And lo and behold, the contractor had no barrier at all. They just had the door open and closing from the OR and basically did not have any barrier protection. This was some of the highlighted things that brought out the original ICRA form. And today you're going to hear me talk about ICRA 2.0, because that's the newest version that we have developed. I have a couple of my colleagues on the line that helped us develop that with ASHI in 2022. But I'll also refer back to the original ICRA that was developed in 1995, because those things still do apply. So the barrier protection is one of the important things we want to do when we're isolating a construction area from a hospital, not to expose the patients. What is the barrier supposed to do? It does a number of things. And when we teach these classes to staff and contractors, I always ask, what's the best barrier? Plastic or hard? And they always get it wrong. They always say, well, hard barrier is the best because then things can get run into, or a plastic barrier is better because it's easier to put up. Well, first and foremost, the barrier has to contain dust and contain the work area effectively, and meaning it has to go from the floor all the way to the deck. We'll talk about what that looks like in a minute, but also has to have some type of fire rating. And this is one of the most misunderstood processes that we see when we're teaching this class. People don't clearly understand that it is a fire rating requirement as well. It protects the opening and stays clean and intact. And so I've seen plenty of barriers put up. I'm going to show you some pictures of ones that don't meet any requirements, things that don't meet the ICRA requirements and the life safety code requirements as well.
There it is.
So these are things that we want to really consider when we're looking at an appropriate barrier. Just a reminder of the ICRA matrix, because we're going to refer to that. We have classes of precautions 1 through 5. If you're not familiar with these, we're not going to talk about them this morning or this afternoon, but just to be mindful, A, B, C, and D are types of work, D being demolition and the most disruptive type of work that we see with the most dust. A is non-invasive, it's really just looking, and then we have low, medium, high, and highest risk areas. The matrix spells out where we put things, so we're going to talk about what barriers fall into these different categories. One, really no barrier at all is required by the original and the current ICRA matrix. However, you may have some facilities that do require that. We'll talk about that. But then 5 being a full containment. So just a reminder, this is what the matrix looks like. The 5 classes of precautions I want you to understand is the first is not supposed to have any dust disruption at all. It's an investigation. You're looking above the ceiling. You're doing something where you're investigating something and really not cutting or making any kind of invasive work activities. Small scale 2 is only for facilities management. This is new. And if you're not familiar with it, this came out with ICRA 2.0 when my colleagues and me developed this format. We added this as a class of precautions because we found about 50% of the hospitals were already doing it, and that's only for facilities management staff. And there may be requirements built into those requirements as what we call standing orders as for barriers. 3 is our first significant process of trying to contain something that could be either done with a handheld device, a shutting of the door, or containing something somehow. It doesn't really get into what that barrier has to look like. It just has to be effective to contain the space. And then 4 and 5 is where we get into the actual rating of the barrier and the barrier type that has to be put into place. So class 1 and 2, I always tell people start with the facility process and the facility policy. I go to probably over 150 different facilities every year, and I know of some of my colleagues have requirements that you have to use an ECU unit anytime you pop a tile. For instance, my friend Richie Stevers, who's I think is on the line here as well, his requirement as his hospital is you pop a tile, you have to have a ECU or a containment unit. That's for any class of precautions, but just remember we train our contractors to ask this question: what are the requirements for containments? Start with the policy. You're going to see many hospitals have different processes in place saying, okay, plastic's good for a certain amount of time if it meets the fire rating and the fire code, or you need to have a hard barrier if it's longer. You have to ask the question. Has to contain the dust at the source, contained locally, not the whole room, but locally. Portable containment units can be used, and it protects the path as well. One thing I'd like to remind people doing when you develop the ICRA and you develop your containment, remember you're going to have to contain spaces just outside the construction area as well, going out to the dumpster or other areas. You need to look at those types of things depending on the risk to the patient. So these are the things that we do in 1 and 2. Class 2, just as a reminder, if you are a contractor, these don't apply to you. These are only for hospital developed policies. We did not put what those are in the ICRA form. We just said that hospitals have to develop their own orders or work plans or standing orders as we refer to them. And so I've worked with a number of different hospitals that have done this. They set up a different process for if I'm going to pull cable or rip up tile or rip up rugs or carpet or anything, I have to have these types of containments up. That is only for hospital personnel. And the reason it matters is some of these small jobs contribute significantly to patient outcomes and infections, and those things have been contributed from facilities management staff back to what we see in hospitals. Okay. I've been doing this for 30 years and seen a number of cases where it was the action of the facilities management staff. So anyway, class 2 precautions are only for hospital staff, and they have to have written policies on how they're going to contain spaces. So we get into why the standard is for barriers and what it actually means. This has always been around. It wasn't written into the original ICRA form in 1995 that was published, but it's always been a requirement. And that requirement comes under NFPA 241, which is a safeguarding standard, which has been around since 1939, actually. And one portion in there, which we're going to show in a minute, talks about containing a space undergoing alterations or construction from a space that is occupied at a lower hazard, or if you have a higher hazard, what you're supposed to do for that. So this standard NFPA 241 is enforced and surveyed by CMS, Joint Commission, DMV, and any regulatory agencies, AAAHC. And also the NFPA 101 standard applies to this as well. Under NFPA 101, there's the requirement for fire watch and interim life safety measures or alternate safety measures, as DMV has, for protecting this space. In addition, going back to the type of barrier, from these requirements is listed in the ICRA matrix and the ICRA requirements as well. And these are all surveyed by CMS, Joint Commission, and DMV as well. What does NFPA 241 actually say, and how does it apply to the ICRA classes of precautions in 4 and 5? It is listed as the item number 1 on the table. In table 5, it says the barrier must comply with NFPA 241. 241 permits the temporary barrier to be non-rated rather than 1 hour rated if you are fully sprinklered. And tarps and plastic and stuff like that's not rated is not acceptable. Matter of fact, over the years, and one reason we asked our colleagues from STARC to talk about their barrier protection is people were using inappropriate barrier protection. It's either not fire rated at all, it's combustible, it doesn't meet any requirements for protection. So the barrier has to be for smoke tight, has to be to control dust, and also has to provide some level of protection for fire. So what does 241 say? It says temporary separation walls have to be at least 1 hour rated and fire resistant with a 45-minute or 60-minute door or opening protection. However, if you are fully sprinklered and your sprinkler protection meets NFPA 13, meaning the sprinkler heads go up, if you take the ceiling tile down or you keep that sprinkler system active, then non-rated walls and openings are permitted when you have that approved system in place. This is how it's looked at from Joint Commission, DMV, CMS as well. So that's what drives this barrier in the beginning, that when we try to teach people, look at the barrier. If you look at this barrier on the slide on the left side, it is a smoke-tight barrier, okay? Is the material smoke-tight? Yes. Is the material fire resistant? Hopefully, yes. But these are the things that we look at. So here's 2 different types of barriers, and we know we have all kind of barriers to think about when we're putting them up and make those considerations for the ICRA requirements. Soft barrier, which is on the left, that's a fire resistant plastic, poly, maybe 6 mil. With a rating. Hard barrier on the right, which is still smoke tight, fire resistant plastic. We have ECU units, and the fire rating again depends on those requirements listed in NFPA 241, and they all have to be smoke tight. Smoke is the biggest thing that we worry about for exposure to patients, because smoke coming out of a construction area is actually going to harm our patient just as much as dust or anything else that's coming up. So it's one of those things that we look at for the fire rating, as well as smoke tight partitions. So what makes a wall dust proof in this schematic, which we go over in the class pretty closely, is it goes all the way to the deck. So that means if you have a ceiling tile that is intact, meaning the ceiling tile is generally 20 to 30 minute rated, an Armstrong ceiling tile, and that's why we put sprinkler systems below ceilings and not up above. That has a smoke tight and some type of fire rating, which is fire resistant. Then you can just put the plastic, and it has to be fire resistant or fire retardant, or a hard barrier that meets the same requirement, such as the STARC barrier or some of the other products that they have they're going to discuss later. If you take the ceiling tile out, then you have to go all the way to the deck with some type of product that meets the same requirement. One thing that we see in some organizations, such as the BAs and others, they dictate that you have to have a 1 hour rating regardless. Or the project manager might say, hey, look, we're going to take the sprinkler system down. We're going to not have smoke detection. We're not going to have all these other things. So we want a 1 hour barrier. This would be an example of a 1 hour barrier, 2 sheets of 5/8 drywall sealed at the bottom and at the top with approved fire rating material. And that would give you the 1 hour rating for the protection to meet the requirements for that barrier under NFPA 241. So here's some examples of ECU units. I can remember in the day where we didn't have these type of things, ECU units, and what we created were some pop-up zip walls, but these things are very clever and easy to use. Most hospitals have them in place, and they'll put in their policy, if you're doing incidental work above the ceiling and you have to disrupt things, or you're in a high-risk area, you would use these ECU units, which are environmental containment units. HEPA negative air might be included depending on the risks that we put into the risk assessment that we do for ICRA, but they are appropriate containers for small spaces and effectively put up in a way that we can contain and control the dust. Here's something that doesn't meet the requirements any longer, never did, and this is a barrier that when I see these type of barriers put up, I really kind of frown because one, it probably was a little bit disruptive to put up. It's a plastic barrier that meets the fire rating. However, it has like a triple flap or a flap. We don't allow those any longer. The flap has to be either a zipper or a containment or a door of some sort. Those are the best methods to show that we are containing the space and making them smoke tight. In this arrangement, that wouldn't meet the fire code or my ICRA requirements or an ICRA requirement at all. So this is a great example of what we don't really want to see in a barrier that's put up in a hospital. So knowing the barrier is step one. The product that you're going to use is can it stay in place? Can it fail? Sometimes we have these projects that go on for 6 months or even just a couple months or a couple weeks, and they can get damaged or they might get knocked down or they might be hard to put up. When we actually developed the ICRA form for ICRA 2.0, one thing that was asked by the regulatory agencies is, please explain to people how to put up barriers safely in an occupied space as to not create dust and debris and other things that might harm patients, and how a wall should look and how should it be inspected on a daily basis and make sure that it's staying in place. So this is a good example of no protection at all. Maybe not the dust as much, but if you have a negative airspace, and another reason we put barriers up is to keep the space under negative pressurization. Well, this is a 6 mil or greater fire resistant plastic that's put up to the deck, and it's a challenge to keep these things in place. That's why we go to other type of barrier systems now that provide a little bit easier things to do. This has always been a challenge. They get torn, they sag, they break. My main concern with this type of arrangement and this kind of observation is that the fire could escape the construction area. So we have really no protection. And also we're reducing our negative air in that space because we have this big hole up in the ceiling. Well, here's some examples. Then I'm going to turn it over to Will to give a little bit more insight. I recently saw this at a hospital out in Texas, and it is a STARC barrier where the contractor had actually put the barrier up incorrectly. And if you see the slide in the middle, there's a piece of cardboard. And this was right in the middle of an emergency department, real busy emergency room. And the barrier had been put up correctly for some portions, but the other it hasn't. So when I had that discussion with the contractor, they just really didn't understand the importance of doing the whole thing correct. And then on the right, you see that the door was ajar. And so as remember, you're going to put up these barriers and have the barriers, as I mentioned earlier, with a zipper or a door. It has to meet the same requirements as we do with fire doors and fire smoke doors in hospital, less than 1/8 of an inch gap. So there's no escape of smoke or dust or anything else. So great example here. I've already discussed these with Will. He's going to go into a little bit more what some of the better solutions are. These are just good examples of things that you look for. Tape not being installed properly in big gaps and holes. Another thing I see quite often is that they'll put some of these barriers up right in the middle of a supply diffuser. So there'll be a supply diffuser on one side and then a supply diffuser on the other. The ICRA requirement is that you close off those diffusers, and they just really don't understand. So they buy the nice products, the right products, but they just don't install them right.
You know, as we all know, ceiling conditions are never just straightforward. They're never just flat. And so the way to properly install on this photo is we've got a number of widths of panels and then a number of accessories. And so you want to try to match the height of the ceiling with those various widths and accessories to try and minimize the gaps. And when there is a gap, because of a soffit, etc., because you've got a fixed width panel, you can use the appropriate fire-rated plastic to cut around and seal up that remaining gap. And then on the door slide, right, So our doors come with a variety of seals, and we have contractors using these products for over 100 reuses. So over time, it's important to check the integrity of the seals and make sure they're intact. And if they're not, we do offer a number of refurbishment items to make sure that those seals stay in good contact and keep providing the seal for ICRA compliance.
Yeah, you make up some good points, and the reason and that some of these products have been developed, and I'm sure the reason your company develops some of these is they're easier to put up, but they have to be put up, and you have some challenges going around some elevation issues of the ceiling, and in this case, in the middle, the elevation came down about 3 or 4 inches, and they didn't use the adapter, or and they could have done it wrong with a plastic barrier or any other barriers as well. So those are great points.
I think it just highlights, right, going whatever site you're going into, just going into with the proper plan, making sure you know the conditions and making sure you know how you're going to install your barrier ahead of time so that you can accommodate those various challenges in the field.
Yeah, when you discuss what you're going to put up, there's all kind of barriers, and where each option can break down is important to understand for the design of your barrier, such as you're going to go 20 feet down a hallway. Plastic sheeting probably wouldn't be the best thing to do because you're going to run into it, maybe with a stretcher or whatever. It might tear. And also keeping the integrity with the negative air requirement that you might need. However, if you're going to construct something with an ante-room or something like that, that might be more appropriate. The drywall partitions, I still see that done a lot, and I don't like it because contractors don't understand that they can't come in and cut the drywall right in the nurse's station or wherever else, and that's been a challenge. So we try to teach them that if you're going to do that type of situation, that you need to make your cuts outside, tape them, and bring them in, wipe down the product, which is another issue altogether with drywall. It doesn't easily clean. And then we have some of the modular panels.
Yeah, and the downsides of drywall is, you're going to have to take it down, and it's just going to be as messy taking it down as it is putting it up. And that's where, in the past 10 years, we've really seen this emerging market of modular reusable wall systems that I'll touch on and is part of STARC's story. So STARC System builds modular reusable walls for occupied renovation. We really got our start in healthcare, and we were founded by a contractor who owned his own business who saw this need within healthcare, but also other types of renovation projects. And he saw this need for a reusable modular wall that provided safer conditions for occupants. And so we really tell our story around these 4 pillars, which is providing a better patient experience, increasing profits because you can reuse these modular walls over and over, providing better protection for everyone, not only workers, but the occupants within the space, and also just helping to make the world more sustainable, where you're not, having to tear down plastic or drywall and just throwing it away, but being able to use it, as I kind of said, for multiple uses. So we really got started within the healthcare world in being part of the solution for ICRA compliance. So we know that hospitals are constantly moving. And so we want to make sure that these wall systems are easy to set up. They're providing the appropriate seal, but also providing the right fire and life safety. So any of our wall systems, we go through a laborious process of testing and making sure that we're certified with Intertech. And so any of our testings and certifications can be found on Intertech's building products directory, and you can pull up and find exactly the type of testing we've done and fire testing that we've done for these walls. So there's 3 products I'm really going to go into that are more focused around healthcare and ICRA compliance, and one of those is RealWall. RealWall is a modular reusable wall that has multiple width panels, and you simply bring panels together, lift them up, drop them together, and that's what locks them together. And it's built with a lower panel and an upper panel that you can telescope the upper panel to reach various ceiling heights. So it has that modularity built in. And really, you only need a 5/32 T-wrench to install these. So when we designed these, we were really thinking about how can we be part of that ICRA compliance solution? So we make sure that all of the perimeters have a nice gasket that seals to whatever surface it's touching, but we also build in features that allow you to meet the negative air requirements. So we have a specific panel that's adapted to connect directly to an air scrubber, as well as ports to be able to hang a monitor and monitor the negative air pressure from the outside. So as Bob was also stating, part of the ICRA compliance is making sure you have smoke seal. The issue with plastic is that it's hard to always get a seal. And so with our doors, we make sure we build in the right gaskets, the right seals, so that these are compliant for being a smoke partition. And so we also have a number of different door types. And so it's really easy to switch in a different door type, whether it's a double door, a sliding door, a hinge door, and the appropriate lock set for the hospital setting. So light barrier is the lighter version of RealWall. So it's lighter weight. It doesn't have as good of a sound attenuation, but it has all of the features that allow you to adhere to Class 4, Class 5 ICRA compliance. And so with both RealWall and light barrier, with these hard barriers, they have a nice cleanable surface that you can go in and clean the surface really easily. RealWall and light barrier can be used when there is an active sprinkler, but in the case where you don't have that and need a 1-hour fire rated wall, we have a system called FireBlock Wall. FireBlock Wall is a modular reusable 1-hour fire rated wall with all of the key components to build out that wall. It's constructed with different sized fixed panels. There's 92-inch panels and 104-inch panels, and then extensions on top of that. So you can build a wall anywhere from 8 feet up to 10'6" with these panels. And we specifically went through very rigorous E119 testing to make sure that this product adheres to the 1-hour fire code. But we also looked at all of the other parts and pieces. So FireBlock Wall also has a negative air panel. So we certified penetrations going through FireBlock Wall as well as our damper connections. So just like RealWall and light barrier, you can also connect a air scrubber and a monitor to monitor the negative air within the space. And along with that, you can kind of see how FireBlock Wall is built up. So it's built up with a perimeter track system, and then your modular panels go within that. And so the panels come in 24-inch, 12-inch, and 6-inch width increments to build out whatever wall size you need. And then within the track, there's also a 9-inch flexibility to cover various lengths. And in the remainder, you fill it with what we call a FireBlock pillow to close up that gap. And all of this is fully certified with the E119. And then along with that, the door is also UL 10C 1-hour rated as well. So it's a complete solution to adhere to that. One point might be brought up of, okay, well, how do I get through the MEP and to the deck with this system? And so that is a challenge. More often than not, a soft fit is dropped down right to the ceiling grid line to be able to attach that upper track into. But when that can't happen, we also have a solution that's called FireBlock Cap, and that is in the upper right-hand portion. And what this is a cap that actually goes on the top of these panels that ties back to an existing 1 hour rated wall. So it allows you to create a bump out, and we'll see some examples and pictures on the next slide. So here's a live example at Kaiser. And so this is a bump out, which they bumped out from an existing fire rated wall. And you can see the cap just ties back right into that wall. So really, it's not a one size fits all solution. And that's why we offer the 3 platforms for healthcare environments. As you'll notice on this slide, we have a 4th product called Stack Barrier. We tend to not sell that into healthcare settings because it's meant to be more modular in terms of cutting it down, and we don't want that dust and debris in a healthcare environment. So these solutions aren't ICRA compliance, but they can be part of the solution to get to ICRA compliance.
Well, I really like these type of products because they solve a whole lot of different problems. For the most part, we see that the barrier can just be smoke tight. When we're doing our planning for projects, we always ask the project management team, can you find a wall that's 1 hour rated to tie back into just in case you have to do these takedowns? Mainly because when contractors take the ceiling tile out, they don't always go to the deck with anything, whether it's plastic or any kind of barrier. So they fail at both those type of things, whether it needs to be 1 hour rated or smoke tight. But my question to the group and to you is, what do you see some of the biggest challenges that you run into in healthcare right now? What are some of the biggest challenges you hear about, Will?
Yeah, some of the biggest challenges I hear about are maintaining a good seal with existing structures. Because as we saw in some photos before, hospital environments are all different. So making sure that a barrier is sealed up against an existing structure is critical. And how we get there with STARC is we offer a number of accessories, such as a wall interface that comes with a gasket that interfaces directly to an existing wall and creates that nice seal against that wall, because you want to make sure that you don't have gaps in your wall, because those are all points that dust, debris can get through.
Yeah. How about transport issues? Do you see that? I mean, the panels come in different sizes, as well as if somebody were to bring in a big roll of plastic or a sheet of drywall to try to do this, I would think it would be easier to handle the product that are modular. Has that ever come up as a question or a concern?
Absolutely right. Because going through these hospitals, you're going through narrow corridors, you might have to go through elevators. And so transporting anything becomes a challenge, and you don't want to be disruptive to the hospital staff. And so the way we tackle that is we offer a cart that these panels are loaded up to, and we actually ship panels on carts. So when they arrive to the job site, you just knock off the casters and you're wheeling that cart right away. And so we've actually designed these panels to be 6'10" from the get-go. And this size is much easier to maneuver around. And we also make sure that the cart's width goes through most common door widths. And so we're thinking about these things to make sure that when you're wheeling panels and wheeling carts, that they're going to fit through and not be so disruptive to the job site.
And Will, how are you handling the handoff with your customers? How are you making sure that they understand how to maintain and put up your barriers correctly? Is there a level of training? With that, we just saw a few photos of some STARC barriers that contractors had put up incorrectly. So obviously you can't hold their hand the whole way through, but once that handoff is made, what do you provide in terms of support?
Yeah, right. So switching to any different products, there's a learning curve. And what I'd like to say is, as people become familiar with it, it almost becomes second nature. But to get there, we offer all of the product documentation to help facilitate how to appropriately install these hard barriers. But not only that, usually people don't want to read a 72-page document, so we offer videos as a reference in a way to properly install our wall systems. And more often than not, these videos can easily be pulled up on a phone, and it will give you the step-by-step procedures to properly install these.
Yeah, and those are great points because we're starting to incorporate those type of videos and others into our online classes, mainly because of the best example I give is you walk by somebody in the ECU unit and they have a big gap between them and the ceiling, right? How many times have you seen that? I saw that actually yesterday at the hospital that I was at. And the whole purpose of the containment is to contain this space. So whether you're putting up a zipper and a plastic containment or a modular containment, it has to be done with some confidence and it has to be done properly and sealed properly. And that's the challenges that I've seen my career where there's been breakdowns. So the fail points that we want to make sure understand is the people setting up needs to understand how to do that. Can we start taking questions from people that might have a question?
Yeah, here's one. It says, if we're using a modular wall, do we still need a rated door or just the rated wall? Do you need ratings on both?
You want to answer that, Will?
Yeah, so you need ratings on both. So it's not just the wall, it's the entire wall system, right? So it's the doors, it's the walls, it's the penetrations that go through that wall. So all of that needs to be rated.
And Will, you mentioned that pillow. So is that pillow something that helps you navigate when you have different poles and things coming down above the grid? Or is that somewhere where you would use plastic above the grid and go up to the deck? Can you
So
explain the pillow a little further?
yeah, I can explain it better. So the pillows go in our tracks, and it allows for increased modularity within either the height of the wall or the length of the wall, because these
Mhm.
tracks go completely around the perimeter, so around the sides and then top. And so depending on the gap that you have between the pillow and the existing structure, you fill it with a certain layer of pillows. And these are intumescent pillows. So in the case of a fire, it completely fills the void to stop fire from transferring over.
Yeah, so those pillows would be the ones that expand during fire, right?
Mhm.
Correct.
And keep smoke tight as well.
Mhm.
Back to your question, Olivia, about what the rating has to be. When we look at the barrier, it has to be all the openings and challenges that I've seen with somebody putting up a single sheet of drywall, which may be smoke tight, but then they put a door that you would see at Home Depot or something that has no rating or it's made of press board, would really not meet the requirements that we're looking for under 241 as well. So those are always the challenges and discussions that we have with contractors. Yeah, maybe it's holding in the dust, maybe it's shutting and sealing, but if there was a true fire in there, it would not contain that as well.
Could you explain how do you know if the area is fully sprinklered? What does that mean? How do you determine that? If what does that look like?
I can answer that, Will, if you like. When you have a fully sprinklered area in the construction area as well as outside, you have the ceiling tile and then you have a sprinkler head, obviously. And as I mentioned earlier, we don't ever sprinkler above the ceiling because that ceiling tile provides some rating as well. And so when you take the ceiling tile out, you can't just leave the sprinkler heads down. That doesn't meet any requirement for fully sprinklered space. So those sprinkler heads, when you do the design of, hey, we're going to take the sprinkler heads and modify them because we're going to have, as most big projects have, all the ceiling grid taken down. then you have to turn them up, and they have to be within 22 inches of or 21 inches of the ceiling, with a ceiling mounted or ceiling type of sprinkler head that you would do in a space that doesn't have a ceiling grid at all. And you see those commonly pointed upwards. So that would be the definition. Do we see that all the time? Absolutely not. Sometimes it takes somebody doing some education and saying, hey, if you're going to have full sprinkler protection, you have to meet those requirements. If you don't have a sprinkler system, or it's just laying there, or it's been capped off, then that's an unsprinklered space. Then that space would have to be 1 hour.
And just to circle back, what are you seeing when it needs to be 1 hour rated and you're having trouble getting all the way to the deck? We touched on it. We showed some things that are wrong. What's the real solution? Probably not one, but what are the solutions to address that?
I'm going to tell you, it is very much a challenge. So there's really a lot of challenge that comes into making that barrier. I see some people do it very well, where they try to manipulate some material around that, whether it's drywall or the plastic sheeting, which is not 1 hour rated. Or they put a soffit or some type of system such as what STARC has to make that soffit and go over. That's pretty clever and easy way to do it, where it can go over from a soffit system, which is a horizontal type of barrier, and then goes up to an existing firewall.
Yeah, with the soffit, and then that way you're not having to knock it down necessarily at the end of the project. You can leave that soffit up above the ceiling line. But the other way that we tackle it, as I was kind of stating before, is with a cap. So bringing that back to an existing wall, so you don't have to go up into that MEP.
Yeah, I mean, the best option, whether you are constructing a barrier with a modular system or drywall, which can be effective as well, is the best method I tell people to do is do your planning in the beginning and say, okay, if I can just go another couple feet here, I might have a 1 hour wall that I could use as my barrier. Most big construction projects that are in big open spaces such as shell spaces and all that do have some kind of rating already all the way to the deck. But if you don't, that's part of the planning and trying to decide how you're going to do that. It is not something that's easy to do sometimes, but it needs to be planned out, because it's one of those failure points that we see routinely when we're doing these inspections.
The last question I received, and we can open it up if anyone else has any, is talking about how to know when to go from class 3 to class 4 precautions. What's kind of the line there, because it's not very clear in the ICRA form.
Yeah, so class 3 precautions, you'll see that it says the space should be contained in some fashion and be neutral to negative pressure. That was one of the discussions we had for a long time when we wrote the requirements. And again, the barrier protection can be as easy as just shutting the door and maintaining your fire protection, or using some other type of containment system. You'll see an asterisk on the ICRA form, and the reason that asterisk is there is it says, so you see class doing A-type work in high-risk areas, we want you to have some kind of effective containment. And that containment could be, some kind of barrier around somewhere, or maybe it's in a solid utility room in an ICU or an OR where you can contain that space, but you're just doing minimal work. A is nothing, non-invasive. There's really not a lot of hazard. When you get to B, we don't allow anything in the highest risk areas other than a class 4 precautions. But in the high risk areas, because B is short term, short scale, we will allow 3 with some type of containment methodologies, which we list in the guideline. When you get to C and D type work, which is more effort in hazard, even in medium and low risk areas, we want you to contain it. However, that asterisk says if you can't totally seal up the space and contain it from a patient care area, then you need to make it negatively pressurized and you need to contain it. The win there was we put this in the guidelines specifically with that asterisk when we're looking at shell spaces. So if you're building out a shell space and you can't totally make it negatively pressurized because it's so large, then you have the option of just not going in and out of the from the construction area into an occupied space. Maybe going to a dedicated stairwell or a buck hoist or some kind of lift outside, as long as you can totally contain that space effectively with a barrier, then we allow that type of barrier protection, and that's what 3 is. When you get into 4, 4 and 5 are the ones that dictate the more hazard and the requirement for some of the barrier protection that we see under 241. The options that we give in 3 may not be what a hospital wants to use. They might want to say, okay, any kind of barrier protection has to have this or that. That's why you got to go back to the policy. But in 3, we give folks an option to use a lot of different methodologies, such as we did in the asbestos industry with glove boxes and glove bags and stuff like that. Same type of thing.
Here's a question that we have in the chat. Who signs off on the barriers that this might be for you, Bob, that they meet the fire rating? Is it the infection preventionist, the contractor, the fire marshal? And is that happening on every project?
No, well, so it really starts with what the hospital policy is. So, we preach to make sure that when you start a job, whether you're a contractor or you're working with the hospital, you first and foremost say, what is your ICRA policy? For instance, there's a hospital here in Tampa where I'm at that has some very specific requirements for barriers. And I helped them write their policy years ago, but they've gone to the point where they say it will be like this. Okay, so you need to ask those questions a lot of times. What you're actually doing for a barrier and what the requirements are. So back to who dictates what the barrier is, whether it's plastic or hard, that's all done during the ICRA team meeting. For instance, if I'm the infection control practitioner and I say, yep, if you want to use plastic, that might be fine, then the project manager might say, well, it would be better to use a hard modular panel because we're going to be doing this for 3 months. So all that gets discussed at that point.
Those are all the questions that I have in my chat. If anyone has any other questions, if not, we will go ahead and give you your time back. You can go to our website and we have our online courses available there, or we have different in-person courses coming up. We also have discounts with STARC and some of our other partners on our ICRA marketplace.
Well, I hope it's been useful. We want to continue to have some specific topics over the next 6 months on a routine basis. If anyone has something they want to specifically hear, but we're going to go over negative pressurization. We're going to go over noise control and vibration issues, some of the other big topics in ICRA, and have some other colleagues come and help us talk about that. But we really appreciate everyone joining us today. And we look forward to seeing you again.
Yeah, and thank you, Bob, and thank you, Olivia. We really appreciate hopping on this call and getting to talk about STARC Systems and the solutions that we offer. And for anybody else out there, don't hesitate to reach out to STARC Systems and help you to get to that ICRA compliance that you're trying to.
Have a good day, folks.
Thank
Good weekend.
you.
Thank you.